Okay, class, right behind me and on the screen for you right now are 4 sets of triangles. And in class, we remembered and had to recall some triangle congruency theorems. We remembered quite a few of them, but let's just recap them by saying them out loud here in a minute. The first one we talked about is something called the side congruency theorem. All 3 sides match 3 corresponding sides of another triangle. All the scale factor of 1, meaning all of them have the same equal measure, that's side congruency. We had side angle side, where the angle in between the 2 sides had to be congruent for both sets of triangles. And the sides, of course, vary by a scale factor of just 1, so they're congruent as well. We also had angle side, and angle side angle, and lastly hypotenuse leg. Alright, so behind me and on screen for you are these triangles. Right? And we're going to use those theorems to see if the triangles fit the theorem and whether or not they're congruent. So the first one we're going to compare is triangle ACB with triangle EDF. Okay, so right now you'll see that this indicator, 1 dashed line, matches this indicator. So we now know that AC and FD have the same length. We also know that BC and ED have the same length because they're marked with a double dash. So we have 2 corresponding sides that are congruent. There's nothing else in this diagram that indicates angles, however. So there is not enough information to compare this one with this one to say this triangle is congruent to this triangle. There's not enough information. So this one is not congruent to this one, even though they look that way. Don't let the diagram fool you. If there's enough information, we can't conclude they're congruent. Let's go to part B. We have 2 triangles here. We have triangle PQR and triangle FED. Again, looking at the indicators, we have this side, PQ, congruent to FE. We have QR, congruent to DE. And we have PR, congruent to FD. Okay, so that one actually fits our side congruency theorem, just for the picture. Great. Let's go to part C. Part C, we have a couple of angles indicated. The angles are indicated with these little arc lines, right? So these arc lines here, this one and this one have the single arc. These are double arced. So this one, angle A, B, C, we could call just angle B. And we could call angle F. They have the same angle measure. Angle A and angle D have the same angle measures. And then we're told here with the dash that BC is congruent to FE. Therefore, these 2 triangles are congruent by angle, side. Angle, side. It does make a difference where those angles and sides are. This is not angle, side, angle, but angle, side. For angle, side, angle, we need a mark in between, which leads us to our last set of triangles. Here we have angle T congruent to angle W with a single arc. We have angle U congruent to angle X by the double arc. And then in between the 2 angles is the side TU with 1 dash congruent to WX with 1 dash, therefore making angle, side, angle the congruency theorem for this triangle's pair.